Alright, this is the flaming tea bag. Mom, help! Yay! And it's falling. For this teabag demonstration to work, the teabag first has to overcome the force of gravity. This happens when we set the teabag on fire. It becomes less dense than the air, so that's why it floats. And when the flame goes out, it's replaced by cool air, and it becomes colder, so that makes it denser than air, and that's why it comes back down. And it works the same way as a hot air balloon. It's like the same concept.
Filming. So make it work.
Fine.
I'm gonna yell at it. Like, I'm yelling at it this time. Do you hear it? Do you hear the static?
Yes. So it doesn't work this time.
Kamaal Shaquiz is hearing the static. Work! Work! Oh my god. Yes. Like, oh. Good. Don't let it touch, remember? Ah. Yes! Aha! Sweet.
Good?
Yes. Yeah.
Alright, for the rotating ruler demo, we charge a PVC pipe and we spun around the ruler, and one end of the ruler continued to follow the PVC pipe. This happened because when we charged the PVC pipe, let's just say it charged negative, the ruler is neutral, so all the protons are attracted to the PVC pipe because they're opposite charges, and the electrons are repelled. Alright, this is our forces of motions demo. This is going to test Newton's first law that an object in motion tends to stay in motion until acted upon by an outside force. And in this bucket we have ordinary old water, and I'm going to spin it around.
Okay, this demo represents Newton's first law, that an object in motion will stay in motion until acted upon by an outside force, because when Kamaal was swinging the bucket, you noticed that at the very height of the swing, the water didn't just fall straight down to the ground right on his head. The water stayed in the bucket and kept continuing in the circular motion. And that's because Kamaal's force swung the bucket in that continuous circular motion, and the water in the bucket wanted to stay in that continuous circular motion. So that represents that the object in motion, which would be the water, wants to stay in motion, which would be the circle, until acted upon by an outside force. And since we didn't have an outside force acting upon it, other than gravity, the water stayed in the bucket and everyone stayed dry. Okay, this is our pressure demo, and what I got here is I just got an ordinary can, and I put a little bit of water on it. I'm going to place this can over the stove burner, and that's going to heat up the liquid inside the can and bring it to a boiling point. And then I'm going to take this can, and I'm going to place it top down in this bowl of water, and stuff's going to go down. It'll be real entertaining, real scientific, real beneficial to the scientific community. So, yeah. And now we wait. It's going to take a sec. So.
And Meshach's wearing jeans today. He looks like a fool.
I do not look like a fool. Handsome young lad. Guess who's back again. Kamaal is back.
Squall.
With a camera.
Camera. And we're burning a can.
Oh, dude, I hope the fire alarm doesn't go off again.
That was terrible.
Yeah, that's what you think.
Like I panicked.
Yeah, my fire alarm is like so sensitive. Like you can like
squall.
Yeah, and then it'll get set off, and it's just like what? And everyone just gets really salty because like everyone's just trying to sleep, and then like Miguel will come down here and try and make breakfast or something. And
Miguel?
Then, yeah, my brother. Like, he'll set off the fire alarm.
He's Puerto Rican.
He is Mexican. No, he's not Puerto Rican. I'll quit it. Did I tell you what Browns had a real good demonstration going over here? Oh, come on, buddy. You're doing so good. Yeah! Should I do it?
I'm scared.
Oh, yeah, I kind of am too.
Alright, when you dump it in, pull your hand away really quick in case you want to explode.
Oh.
You're gonna explode, Meshach.
I'm gonna explode?
Yeah, just you.
Oh, I hope so.
The can's not.
The can's gonna be fine. I'm gonna,
You're gonna explode.
I'm gonna spontaneously combust and just
There's gonna be like beach quack guts all over the wall. We're gonna have to clean it
The
up.
worst kind of guts.
Yeah. Alright, you ready for this? Okay, I am going to put the can upside down in the water, and stuff's gonna happen. Please God. Yes! As you can see,
Pull it out, pull it out.
the can has been
Oh, squall.
the can has been crushed, and it also filled with water because I dropped it because I got squelched at the noise. But the can has been crushed, and I did not use any of my awesome muscles to do this. This was all due to pressure, and that's our demo. Okay, so when I tipped the can upside down and sealed off that opening through, like, in the water, it crushed because the atmospheric pressure outside the can was a lot greater than the air pressure pushing out inside the can. The average atmospheric pressure per square inch is about 14 pounds, and since the can is about 49 square inches, it was approximately 720 pounds of air pressure pushing in on that aluminum can. The reason the can doesn't just crush automatically if I just hold it in the air is because the same air that's pushing in on the can is also inside the can pushing out. But when I put the water in there and I boiled the water in the can, the water vapor was pushing out the air inside the can. And since the water vapor pushed out a lot of the air and I quickly tipped it over, sealed off the opening, so that means no more air can get inside the can. So the water vapor pushed out a lot of air, no more air can get inside the can because the can's sealed, and then we have 720 pounds of atmospheric pressure pressing on the can, and the can crushed. Alright, so I just washed my hands for the first time in like 4 years. So what am I going to do now is I'm going to rub my finger against the rim of the cup, and it's going to create friction, and it's going to make a noise. So get ready. Okay, so what happened was when I rubbed the rim of the glass with my finger, the friction between my finger and the glass caused the glass to vibrate. And this vibration of the glass caused the air inside the glass to vibrate. And when the air vibrated, it produced a sound wave, and that sound wave transfers to the noise that you hear, and that's where the sound comes from.